these you should you'll see in class from the lectures. Flatten and dense. Okay, so we're first going to we first initialize our sequential. Oh, actually, we didn't even import that. From Keras.models import sequential. Okay. So now that we have a sequential model, we can start adding to it. So net.add, and we'll add a convolutional layer, and you have to specify the number of filters. For now, we'll just leave these as variables, and then we'll populate them later. So kernel size is whatever the kernel size is, whatever we decide. Padding, so there are two kinds of padding. There's same padding and then there's valid padding, and you can play around with these two to see how they work. I'll probably do another video on what the difference is between same and valid, but it just has to do with how you handle the last few layers when you're passing the convolution filter through the image. And then activation is relu. Relu activation has shown a lot of promises when it comes to being an activation function. So since this is our first layer, we also have to put an input shape, and the input shape is going to be the training data, that shape from 1 to the end. So if you could look over here on the console, we have 50,000 32 by 32 by 3, right? So what we're going to feed in is going to be the first 32 by 32 by 3, and then the second and third and so forth. So x.shape from 1 to the end will just be these three numbers here. Okay, that's our first, and then we're gonna add now the max pooling 2D, and this is going to just take a the pooling size, which we'll also call pool size. So these variables here that I'm writing in capital letters, these are what you call your hyperparameters, so we can place that over here. Now, hyperparameters, these are I guess, parameters that the network does not learn. So they have to be provided. So they have to be. That's something very important. And this is what makes deep learning so difficult. So we're gonna, this convolution max pooling, we'll do this, let's say 3 times. Again, the amount of times you do this will vary. You just have to keep rerunning the model to see how your accuracy changes and things like that. So first let's define our filters. So let's start off with, I guess, 16 filters and a kernel size of 5. I'm just guessing numbers here right now. Pool size of maybe 2. So the kernel size is that convolutional kernel that's going to be going through the videos. You want this usually should be an odd number. Then the filter is how many filters. Initially you see we have 3 channels here. We will then up that to 16, and then the next layer we should probably double that to 32, and then to 64. Because that's how convolutions work, right? You're taking this image and you're trying to stretch it out in the other dimension. So after we've, oh wait, so we don't actually need the input shape on all of these. This is the bad part about copying and pasting. Carry the mistake all the way for each of them. Okay. So after we've done our convolution, then we have to flatten the model so that we can actually make predictions and get numbers that we can then check with the one-hot encoding. So after we flatten it, then we'll add a dense layer, and again, this could be as many nodes as you want, and an activation. And let's add that to our hyperparameters. Dense equals 256. Again, could be any really any number you want it to be. And then finally we'll add our last dense layer. We could add another dense layer here also if we want, but for now we'll just leave it at that. And this last dense layer has to be the number of classes you're trying to predict, and for us it's 10 classes. You don't need this here. You could always just add another dense layer again if your computer has the processing power. But for demonstration purposes right now, we don't need to go there. And our activation. And again, with the last one, with the last layer, your activation function here is also very important. So here we're using the softmax activation function because we want to have probabilities. And with the 10 classes that come out, the one with the highest probability will be the one that will, in the one-hot encoding over here in the terminal, that will have the value of 1, and all the rest of them will be 0. So it could be compared to the actual testing set. Okay, so that's our model. Let's take a look at it. So we'll do net.summary. Alright, let's quit this and rerun it. Okay, right, I called the function here. Alright, rerun that. Okay, so we got a syntax issue. Ooh, extra pair of parentheses in my max pooling. No, I think this is correct. Why is it complaining? On line 62. Oh, I forgot a pair of parentheses here. That's why. Okay, let's try this again. Oh, padding. Wow, too many D's. Too many D's. And while we're here, we don't need to keep printing out these values. It's okay. We know what the shapes are. What did I misspell? Activation? Come on. It's embarrassing. Alright, let's see how it's supposed. Which one is it? Okay. Alright. So this is our model, right? Convolution, max pooling, convolution, max pooling, convolution, max pooling. Then we flatten and we have 2 dense layers. So we have about 1/3 of a million trainable parameters. Okay, so before we train, let's just create some checkpoints so that we can save our model as it's training. There might be certain weights that are better than others through each epoch. So you want to save the best ones, and you can do that in Keras by using a checkpointer. Well, actually, it's called a model checkpoint, and this also needs to be imported. So we'll put that over here. So from Keras, I think it's callbacks. Callbacks, import model checkpoint. All right, and what you have to provide is a file path. So what I like to do is sometimes call my model, name my model with the hyperparameters that I have. You could really name this anything you want, but I find this helpful. This way, if I have multiple models, I know the difference between the weights, or how these weights were produced. Okay, that's what I'll name it. And verbose. Now these are all just cosmetic parameters. You just want to see it, and of course save best only. This is exactly what I was talking about. You want to make sure you're saving the best ones. Okay, and now we can actually fit our model. So net.fit xtrain ytrain. Now earlier we didn't split the data, the training set, into a validation set because Keras allows you to do that in its fit, and we're going to use 20% of the training set as validation, and then epochs will equal epochs or epochs, depending on what you want to say, and also our batch size. These are also hyperparameters that we need to add up here. So epochs. Now for this it should be a lot more than 10, but for this tutorial we're just going to use 10, because anything higher, or the higher you make it, the longer the video is going to need to be. Alright, and now we use callbacks and we can add our checkpointer. Oh yeah, we will need checkpointers. Just this one checkpointer is what we'll be using. Alright, and let's let's take a look and watch our model train now. Hopefully all went well. Nope, of course not. Let's see here. Unrecognized argument callback. Is it callbacks? It's with an S. Oh, wait, no. This is embarrassing. We never compiled the model.